Today we have Alex Mendes from the University of Newcastle. Welcome, Alex.
Thank you so much for having me here. It's a pleasure to be here.
Cheers, mate. Oh, well, for the people that don't know who you are, can you give people a bit of an overview of who you are, what you're currently doing?
Yes, so I am a senior lecturer with the School of Electrical Engineering and Computing at the University of Newcastle. And I've been there for 16 years now. I'm originally from Brazil, from Rio, did my studies over there, and came to Australia in 2003, straight to the university as a research assistant. After 4 years, I became a lecturer, then a senior lecturer. So in total, 16 years, and I work with computer science and software engineering. My main areas of research and teaching are artificial intelligence and optimization. And that's pretty much what I do.
Nice. So you would have seen, obviously, the Newcastle technology scene change quite a lot over the past couple of years, but you've been within that field for 16 years now. What's the biggest changes that you've seen in both the ComSci degree and also Newcastle, how it relates to, are we having more people go through? What have you seen?
Well, a lot of things have changed. Again, back in 2003, the city was completely different. I used to live in the CBD back then, and the city, like the whole CBD, was pretty much empty, and now it's much more alive. The university, the degrees, they have changed a lot. They are much more current in terms of what they teach. There is much more industry involvement as well. We have changed lots of things. One of the things that I hope we touch today as well is work integrated learning. There is a very strong collaboration now between local businesses and the university. Also, computer science has changed a lot. Like 16 years ago, there was no artificial intelligence, at least as we know now with the whole deep learning and deep neural networks that are coming through. There was nothing like that 16 years ago. And cloud computing also was not really much part of the scenery. And it has changed a lot.
Yeah, nice. So you mentioned the work integrated learning there. I know it's a passion piece of yours as well. And I think it also provides a significant change from a degree that's just purely in a classroom. I think once you do start to integrate that work integrated learning, it provides a lot better pathway from a degree into the workforce. Talk to me about what you've seen from a work integrated learning perspective, some successes that you might have had.
Yes. So I am the course coordinator for work integrated learning. It's an actual course, so you get credit for that. It's different from engineering, that they have a industry experience of 12 weeks. So for computer science and information technology, you have a course that goes across 2 semesters. And students taking that course, they choose a project that they have to conduct throughout the year. And what we do is we invite companies. So we have a list of companies that help us in that regard. We invite companies to put forward small projects that either an individual student or a group of students can take from start to finish over 1 year. And then we publicize those projects to the students. The students choose their preferences. And then I send their documentation to the company representative. They run interviews, so it's like a job application. And then they pick their preferred candidates. I do the matchmaking, and then the student can start, working for a business here in the city. It's been very valuable for both businesses and for students, because what we teach in the classroom. So before I go there, it's very interesting how university behaves or how it moves. It's a very slow moving kind of creature. Like we have to be careful with how we change our degrees, or what we include and what we remove, because we have to kind of serve several masters. Well, we have the students that have to learn. We have the companies that we will employ them afterwards. But the future employers of students, they come from all different places. Some of our students, they want to become scientists. Some of our students want to work for businesses. Some others want to have their own startup. They have their own ideas. So we have to kind of cater for all of those different profiles. And also very interesting is that, and not many people know that, is that we also have to abide by the rules that are given to us by the Australian Computer Society. Our courses, they are accredited by the Australian Computer Society. And they have very specific rules about what needs to be taught and what should be included and what does not need to be included in our computer science and information technology programs. So we have to try and find the sweet spot, so that everybody is served at the end.
Very difficult.
It's not an easy job because we get sometimes complaints, or not complaints, but requests from companies saying, I really wish university students came out ready with these sets of skills, but those are sometimes particular to that company or to that sector. And then we cannot really include that as a core part of the program because that's only relevant to that specific type of business. So we have to look at all these aspects. And that also falls into the program convener role that I have. But we can talk about that later, perhaps. But about work integrated learning, yes. So we send our students to work with local companies, and they spend 1 year there. They have this experience of working at a real workplace instead of just doing assignments and group work, with their colleagues at uni. They actually go out and they might work in an office and with a desk. And then they feel how it is to actually work for someone, and not only for grades. It's very interesting to see that many of our students are work ready by the end of this. Every year we get a percentage. I would say 20% perhaps of our students that end up being employed by the business that has taken them.
Yeah.
It's a kind of like a tryout.
Try before you buy, yeah.
Try before you buy. So they spend 1 year with that student, and then they go through all the training process as any other staff. And then sometimes at the end of work integrated learning of that year, the student, they see that student as a valuable, future employee, and then they keep that person, among their staff.
Oh, hey, I've worked with a lot of companies that actually really do value that work integrated learning and the opportunity to help future employees or just the next generation get those work skills, because I think there is a difference between, what you learn in a classroom and what you learn, within a workplace. And for organizations, it's a really good opportunity for them to help build the community, contribute to the community on helping the next generation. But also from their perspective, they do get some value out of it from those students being able to provide value over those 12 months.
Yeah. And the other thing about work integrated learning is that it's the first time that most of our students will be engaged in a large project, sometimes working with other people. Most of our courses, they have short assignments, like short assessment items that are normally done over the course of 3 weeks and so on. Even group work, it never extends over long periods. So work integrated learning is really the first time that they have to work in larger teams or work at a company with a kind of a boss, and other people that they have to have meetings with and so on. So it comes with the whole experience.
Yeah, and that's such a big part of work life, whether it be a technology professional or otherwise, but especially for technology professionals, you get a lot of technical know-how from a university degree. But the secondary side to that is how do you actually take that technical knowledge and work within a team, work with others in achieving an outcome. And that's really difficult to teach in a classroom or in a project even. As you said, those projects are shorter in time frames, don't have the same hierarchy, don't have the same nuances with working with different departments. So I think that work integrated learning teaches what is really one of the most valuable skills for a valuable employee.
Yeah, one of the things that we try to address with work integrated learning is soft skills. Our courses, they teach really well the technical skills, so that's not a problem. That's not an issue. But soft skills, they lag a little bit. Work integrated learning comes to try to fill that gap. So we teach students everything from how to write a report, or to how to prepare a CV, how to prepare a LinkedIn profile page, and how to conduct himself or herself in meetings. It's simple things like, if you're working in a group, who is going to be the team leader? What does a team leader do? What are what are the tasks? How do you assign tasks to your colleagues? How do you make sure that they are delivering what is expected? How do you set expectations? So those are all soft skills that are not really covered in our courses for the most part. And then we try to cover those in work integrated learning, both with lectures, because work integrated learning also has face-to-face contact hours. So we try to teach them in workshops and lectures, and then we hope that the workplace is also going to expose them to this kind of knowledge.
Yeah, nice. Well, I don't think I've come across anyone that doesn't value work integrated learning. I think I've come across many various conversations around the value of a university degree in total, but the work integrated learning is one piece that definitely gets a lot of positive reviews time and time again. You mentioned just before the technical skills, and the technical skills are taught well. I think one of the conversations that does come up is that relevancy that you mentioned before. If you're doing a 3-year or a 4-year degree, what you learned in that 2 years, with the speed of technology changing, how does a course stay relevant in what you learn in year 2, year 3? Is that still relevant when you come out? Is that relevant to the market? You mentioned before the challenges of putting together a degree and the different people that you've got to please when putting that together. Do you have any thoughts around that relevancy and the speed of technology changing, and how universities can stay relevant?
Yeah, it's a very good question. The way that the university organizes its programs is very well thought. Like, first year gives you the foundation, so it's basic programming, databases, so all the basic things that any person that deals with computing needs to know. Second year, you push those skills a little bit forward, but you are still a very like generalist, computer scientist or information technologist. Then the third year is where you actually get those skills that are marketable, that you can actually take to the workforce. It's only really at the last year of the degree. And when you see the history of each course, how it's taught and where it's taught, first year, second year, or third year, the first year courses, they stay pretty much like the same for many, many years, because those are the foundational skills that don't really change much. You might change a language, a programming language, but everybody needs to know what's a for loop or what's an if statement. Like, those are basic concepts that anyone who does programming needs to know. Then the second year courses, they change a little bit more often, but not a lot either. They stay very, very kind of static, by the lack of a better word. But the third year courses, those change a lot.
Yeah, nice.
Because those are the ones that are closer to when the student actually leaves. And those are the higher level skills that the student needs to learn. So those courses, they go through frequent course reevaluations and reviews, and they do change a lot. But again, we cannot offer courses that are way too specific, because again, it's going to be relevant only for a very small portion of our students that will go and do a very specific type of job. We try to avoid giving students kind of credentials. That's not the purpose of universities. Like, universities, they have to teach students or provide students the tools on how to become self-learners and know how to, like, where they should grow and what kind of skills they still need to, to acquire after they finish. So this kind of vision. So university is about vision, not much giving them just simply skills.
Yeah. The best part I heard just then as well is that the ability for students to come out as self-learners. One of the very common answers I've had to people that have done degrees, one of the biggest benefits has been around that ability to learn, the learning to learn, setting people up so they know how to learn. They'll be better learners in the future because, like you made mention there, and people are seeing it, whether they're out as a student or further in their career, you're going to have to continue to learn. Technology changes so quickly anyway. Having a core skill being taught to you at university, even if it's the most relevant for that day, is maybe not going to be relevant in 2 years' time.
Yes.
Having the ability to learn and pick up that new skill that is relevant in 2 years' time, and then again in 3 years and 4 years' time as technology continues to change, is the core skill that's of utmost value.
Indeed.
I think that ability to learn, the learning to learn, that, as you said, the self-awareness around or self-learning is massive. And for me, that's probably my opinion, the biggest thing that university provides.
Yeah, and interesting in that sense, computer science, information technology, these are fields where you can learn without a university, right? You just go to YouTube and you have tutorials and videos and the whole web, like YouTube channels dedicated to different technologies and with full courses that are like 14, 18 hours long. And so you can pretty much learn by yourself if you want to, if you have the ability to do so. So what does the university offer? When I think about universities, I think about not much providing students with only the technical ability of doing a job. It's about that, of course, but it's about all the other skills, all the soft skills that if you are at home just learning a new language or a new framework, you are not going to develop those. You might be very good with using that particular tool, but you are not going to be exposed to, say, group work or how to do presentations, to a live audience. Those are things that you are not going to practice. Also, the university offers you structure. So in the beginning, you might feel kind of lost about what you should learn first and then what comes next. What is the foundation? What's the specialization? The university offers you this structure. And this is very important because if you take something before you have all the background required to learn that properly, you might lose motivation and then you might think that you didn't learn properly and then you have all these gaps in your knowledge and then eventually you might just drop out of the career, So university offers structure, offers guidance and offers the whole experience as well as being part of a community. So that is all these different aspects that I like to raise. And sometimes people forget about that, and that's probably for me, that's the most important part of uni life.
Yeah, I agree. You made mention of short courses. Where do you think the likes of YouTube, Code Academy, other online short course providers fit into a career for a young or an upcoming, it's called not even software, just somebody, a technology professional? So if you're guiding somebody from a career perspective for a technology professional who wants to build a career there, where do you think the likes of those short course providers fit into a career?
They're very important. What I think about uni is, again, our courses are very short. They are only 3 years long. Some of the people listening to this, they might think, 3 years is a long time. Yeah, but actually it's not. So 3 years, and especially considering the breadth of what you have to teach in those 3 years. So pretty much what happens is that you have to teach those skills, those technical skills and soft skills, but you cannot really cover every single aspect of computer science or IT. It's just impossible in 3 years or even 4 or 5. So what the place that I see for these YouTube channels and online learning, groups is, okay, you've learned this particular tool or language or framework, and you say, wow, I really like this. I would like to know more. And I want to specialize in this. I see myself developing or building a career in this area. Then you go online and then you become an expert. You're never going to leave uni as an expert in anything. Now, you need that experience. So then you can go online, you learn that more deeply. But now you learn that with all the tools that you got in your first and second years.
Yeah.
And then you go online and then you learn more about a specific tool, and you get all these credentials from LinkedIn or all these different places. And then you can become more job ready, which is another buzzword that is out there.
Yeah, I agree. I think from what I'm hearing from you is really like the university degree is for a technology professional, a really good core platform of which to build upon. You can build your work integrated learning on top of that. You can build some short courses on top of that. And as you want to, as you said, go more niche in your career and become an expert in an area, you continue to upskilling in those areas. But at the core of it, the base of your career of which to build upon is that degree to start with.
The base is there. Exactly. Yeah. The foundation is there.
Yeah, I agree. I think I look at it from a foundational piece. As you said, you can't teach everything in there, but you do learn core principles and that ability to learn ongoing. So
yes.
Nice. You mentioned before, I heard it, I'm just like, come back to this. AI. I don't know, it's been a passion of yours. It is something that you are passionate about.
Yes.
Some people out there in the world are scared of AI.
And they should be.
Yeah. AI may not influence your profession or education as a whole. Where are you currently sitting on AI as a topic? What's your overall thoughts?
Well, I've been working with AI for a long time, pretty much since I finished my undergrad studies. I started with optimization, which is an area of AI, and it's really my passion. I love that. What I see, like in the beginning, AI was more about automation and making processes more efficient, and in some places are replacing people in factories and in businesses and so on. But it was very localized. The thing with AI now, especially in the last, I would say 6 to 7 years, with this new area of deep learning and deep neural networks, which is like everywhere now, is that it has the potential to take typical human tasks in a much more like spread in general way. So I'm going to give a couple of examples here. I'm not sure if you have seen a video that came out from Google that was probably a few months ago. It's not a year ago, and was this Google personal assistant. What they tried was, okay, I want to order a pizza, and the person told the personal assistant, which was just a kind of a AI software in their phone, to order a pizza. And then that personal assistant already knows what is the nearest pizza place, and then calls the pizza place, and then someone answers the call and starts talking. And this assistant behaves exactly like a human would behave. The voice sounds human. It's not this robotic voice that you see when in YouTube videos, of just a robot reading a piece of text. It was very natural. It had all the human interjections, like the pauses, and it was very clever. And it could adjust for unexpected questions from the human side, from the human on the other side. So if the border should have cheese or not, and then the AI could actually answer that. That's a very telling anecdote. that AI is really getting very close to be in a normal conversation. Pretty much, you won't be able to decide who is human and who is a computer. And then when that actually happens, you can apply that technology everywhere. You can apply that to customer service. You can apply that to telemarketing. You can apply that to like pretty much any kind of human to human interaction that follows not a precise recipe of steps, but you can provide some context to the conversation. AI will be able to do this. And then the job displacement, the number of jobs that will be lost will be huge. So my main concern with AI is not that robots will take over the world. That's not what I'm concerned about. What I'm concerned about is job losses across several industries, and we are not prepared for that. So that's just one of them. And then we have self-driving, vehicles and trucks. When trucks become self-driving, you have all those truckers, without jobs, and cars become self-driving. Uber drivers suddenly have nowhere to go. So the AI is taking a turn now because of technology, mostly, that it might have a very strong impact, and we are not both either aware of those impacts, and we don't seem to have the will to take the action or take the actions to prepare society for those impacts. And that's dangerous. I find that very dangerous.
Yeah, I think the thing you mentioned there is there's a lot of industries that most people wouldn't even think about that technology, AI in particular, will affect. I think people are aware that there's some repetitive tasks that will be taken, but it's not even the repetitive task that manufacturing starting to or has already taken over. It's other jobs which other people might think, oh no, humans will always do that. AI will have the capability to take those roles.
Another example that I like to give people to say, look, this is not only like jobs that are repetitive or like kind of simpler, in a way. Probably that's not the best word, but if you take, for instance, the role of a GP, okay, when you go to a GP office, you go there, and then the person asks you a set of questions, and then you answer, and then hopefully they provide you a diagnosis or refer you to someone else, to a specialist or something, or ask for some tests. That is the kind of interaction that can be easily automated. And you just, instead of going to a GP's, office, you just go into an empty office with a monitor. If you want to have a more personal, experience, you can have a robot on wheels, and the robot might ask you these questions in this perfectly nice and calming voice, and then you answer, and the robot already has the experience of hundreds of thousands of similar interactions between a patient and doctor, from all over the world, and in all sorts of diseases that were detected. What were the questions that were asked that led to that diagnosis? And they have this almost infinite knowledge. Yeah. And then you go into this office, like this GP practice, and then after a few questions that are asked and you answer them, it will provide, the system, the AI will provide a diagnosis that is probably going to be way better than your average GP.
It comes without bias, right, as well?
Comes without biases, yes. So the point that I see is that replacing these types of jobs with AI is going to be much more a matter of humans feeling comfortable and being confident in the machine than the technology itself. So it's much more a cultural change than a technological change. But that's just an example of a job that you think, wow, this job is going to be safe forever. And that's not the case at all.
In your opinion, how many years are we talking before these changes started take place and really affect us?
Look, it's a cultural change. Like technology-wise, this should not take more than 10 years from now. This should not take more than 10 years. Now, culturally, it might take way longer. Like, of course, if we're going to get rid of all the GPs because it's cheaper to run, a computer terminal to do the same job, that's going to be huge pushback from the entire class, of doctors and practitioners. Once that is overcome, then the change will take place in no time at all. So the main hurdle, to be overcome is humans, is people trying to protect their niches, And
that's a big change. It's a big change. There'll be a lot of people trying to protect their jobs. There'll be a lot of government influence there about affecting job loss.
Which is fair. It's 100% fair. You take mining, like you go to a mining site now, the level of automation is huge.
Yeah.
A few years ago, we could talk about truck drivers in mining sites earning $120,000 a year, $180,000 a year, because they could take the truck like from one end of the mining site to the other end of the mining site and dump the whatever load they are carrying, and then coming back and doing that 1,000 times a day. Now they are putting like self-driving trucks and replacing those jobs. So of course it's a terrible loss for people that have been involved in that industry, in potentially like they have invested years in upskilling themselves to take that highly profitable job. Sometimes that has an impact in their families and so on. And now comes a machine and takes that all away from them. So that's why I'm a bit concerned with the social aspects of this change. It's a change that is completely different from anything that we've seen before, and it's going to make the industrial revolution look like nothing.
Yeah, I don't disagree at all. I think those changes are definitely coming, and it'd be very interesting to see how long that takes. And what the impacts on society are, because I think that the fear is driven, and it's a very real fear around job loss. And it's not only some people have the fears, hey, machines are going to kill us all and things like that, which are very far fetched. But they're in movies and whatever else. But there is a genuine fear there for job loss and how it will affect people, because you have a look at what we went through with COVID just recently. Job loss and mental health and society are all tied in extremely tightly together, and trying to manage that as a government, as a society, will be extremely difficult.
This is going to be, challenges will be everywhere. And the other thing that people are raising now is the prospect of wealth concentration. Because the company that builds, say, the first system that replaces a GP, imagine replacing all of the GPs in Australia. How profitable that would be for a company.
And Australia is small.
Australia is small, exactly. So what do you do with all that money that the company makes? Like, how do you tax that company? How do you give that back to the society and to the people that got unemployed now because of this change? So there is a lot of ethical questions to be asked and political questions to be asked. And so it's not only technology. Technology is very important, but we need smart people discussing these topics, because they will be central to how Australia does in the next 10 or 20 years.
I think it's a very real challenge. Very real challenge. You're obviously a very smart fellow. I know we're having this conversation now about AI. I've just got a note here. You've co-authored 84 publications, including 6 books, 25 journal papers, 53 conference articles.
Yes.
Where did that passion start?
When I was in a uni, I was pretty much like any other student. I didn't really know what I wanted to do. And then the opportunity came for me to do an internship in a research center, and I applied for that, that scholarship, and that completely changed my my vision, my life, pretty much. I just found this new passion. It was the internship was about optimization, and I was using my skills in something that was useful. And so at that very moment, I decided, no, I want to become an academic. So I that's what I wanted to do. I saw my supervisors and how they would have their daily lives. And I said, no, that's what I want to do as well. So I did that. And after that, I went straight for a master's, program and then PhD. And it's just part of the job. You, as an academic, you have to publish, because it's not really that you have to publish. It's more about you do research because that's what you like to do. And at the end of the research, what do you get? You get, results, you get software, you get technology developed. But in academia, you are not looking for intellectual property. You're not looking for commercialization. You don't really, care about any of that. So what do? You publish papers. You explain what you did, what were the techniques you used, and which results you achieved. So when you do that like 3-4 times a year, which is kind of normal, especially if you work in a group, not by yourself. So, but suppose you were working in a team of researchers, say 3-4 researchers, and you are all helping each other. Like every now and then, one of you will come up with a result, and then everybody is part of that paper. It's not that I'm the leading author in every one of those 84 publications. It's that I was part of the team. I helped them in different ways. Some of them I am the leading author. Some others I'm the last author.
Yeah.
But that's how it goes. So someone who has been doing this for like a long time, like over 20 years, that number is not that impressive. Okay, so if you talk to any academic, anyone who loves what they do, they will have similar numbers. It's perfectly fine.
And when it comes to the books you've written, what sort of topics are we talking for the books?
Again, it's all about optimization, and those are more book chapters.
Yeah.
So what happens again in academia is you have an editor, and who is normally an expert in a field. And then they put forward these kind of call for chapters. And then if you want to make a contribution there, so suppose someone's going to write a book about artificial intelligence, something like that. And then so they send, this call for, chapters for the book. And then people all over the world, submit their chapters or their ideas or their results to that. And then the editor compiles the book and then publishes that. It's different from a novel or anything like that. It's very technical, and like each chapter is kind of independent.
Yeah.
Even though as a whole, like they
bring it together.
They bring it all together. So that's the idea. So I've had a few book chapters, yes, publications in conferences, and also publications in scientific journals.
Nice, very nice.
Yes.
How does somebody go about doing all that whilst working a full-time job and bringing that all together? That's a lot of work. It's a lot of responsibility. Do you have any secrets, any productivity tools, any advice that you would provide to others in whether it be prioritization, productivity, in and around those areas? Yeah.
First, I will touch briefly like how academics work. What is the reality of academic life? So academics, they spend 40% of the time teaching and in teaching related activities, either face-to-face teaching or preparing exams, marking exams, and preparing lectures for the following week and things like that. 40% of the time is research, which is writing papers and doing research and supervising students like PhD and master's students. And 20% of the time is service, which is like participating in university committees and making decisions and like about how the university is run or the school is ran. So there's this 40-20, division there. So research is just part of the jobs, 40% of my time. It has to be. In terms of productivity tools, I kind of have to follow what the university uses, which is Office 365. and Microsoft Teams as well. I use that pretty much every day, Outlook. But outside of that, but again, that's just because that's the system that the university provides to all academics, so you cannot really escape that. But I also use Slack for communicating with my students in groups and research groups. I use Slack. I use Notion as well for organizing my tasks. And I used to use GitHub for software development. But to be 100% honest with you, I do very little software development at the moment. I'm more I see myself more as a manager. The way that I did, like when I was a master's student or a PhD student, or when I came here in the first few years as a postdoc, as a research assistant, I used to do a lot of software development. But once you become a lecturer, then your role changes, right? You become a teacher, and then you start to supervise students, and you start to be part of all these committees and going like meetings every day and all of that. And then suddenly you stop coding. Like you only do coding only if you want to prepare a question for an exam and see if it's right. And who does the software development? Your students do. So the ones that you are supervising. So my master's students and my PhD students, they will do the coding just like I did when I was, 20 something. But right now I do very little software development, and that's a shame because I really love coding. I use Eclipse until a few years ago as my IDE. But like, to be honest with you, it's been a long time since I actually coded anything.
No, it sounds like you've got enough other things on your plate at the moment. There's only 70 hours in a day, right?
Yes, indeed.
For anyone else that's sort of obviously impressed by what you've done or seen your career, is there any books or podcasts or pieces of information that you'd really recommend for people to consume?
Normally what I do is, I read papers, scientific papers. That's what I read most of the time, that are relevant to my research or to specific areas of my research. In my kind of free time, what I do is I watch lots of podcasts. I like a couple of podcasts in particular. There is one from Lex Friedman from the MIT, and he has this podcast that specializes in AI. He has very good, people that he interviews. He releases like a couple of episodes every week. And they're very long. They're like 3 hours long. But they are amazing. Like he interviews like scientists and movie directors that make movies about like AI and so on. So it's a very wide range of people that he interviews. I also watch Joe Rogan's podcast that is very famous. And I follow Elon Musk, of course. And I also follow Google's DeepMind group. And so there are a few places that I go, but just again, because I like artificial intelligence, that's my niche. So I go to all these places, but it's mostly papers. There's another one that's very good called 2-Minute Paper. Yes, that's it. So that's a very interesting one because it every week, the person who runs that YouTube channel, they take a paper, a scientific paper, and then goes through that paper in 5 minutes, explaining in very simple terms, like what it does, what the impact is, and so on. It's a very interesting channel that I follow as well. And books, I'm a very I love sci-fi. So I read all the authors, Arthur C. Clarke, Asimov, and so on. Movies. Yeah, all the sci-fi and TV series, The Expanse. I'm watching now, and movies, 2001, Ex Machina. All these famous movies are really awesome. Yeah, but like if you like the area, you consume information both in a technical way and in a kind of more cultural way as well, for entertainment, I guess.
Nice. If you had to provide some advice to, let's not say a younger version of yourself, but somebody that's going through the university degree or starting to look at a career in technology, is there any one piece of advice that you would give to somebody?
Okay, so first, if it's someone already at uni, my advice is try to go to uni and take as much advantage of what is offered to you as you can. And what I mean by that is don't go there only for the courses, like sitting for a couple of hours, watching someone talk to you, and then after you're done, you go home or you spend some time doing an assignment, and then you submit, then you get a score at the end of the semester, and then you are done. Universities, they offer much more than that. It's a whole experience. So there are research groups, there are scholarships, you can participate in very advanced things. And you don't have to be a final year student to do that. You can be a second year student. So for instance, I am part of a team of robotics at the university called Nubots. And those are soccer playing robots, right? And we take students. It's unpaid. So it's students who really want to take their knowledge and apply in something exciting. Yeah. It's something that they can then develop other skills. So it's just a research group where people go there on a voluntary basis, and they work with these amazing robots, that can walk, that can kick, that can, see things, and it's all autonomous. So we use a lot of AI in those robots to be able to see the ball, to see goalposts, to see the field lines, and to actually walk. Only walking is very hard. And so students can take advantage of that. Like we have this team, there are many others, around. So if you're a student and you are in your second year, try to find those spots. They are everywhere. It's just a matter of finding them, and then take advantage of that. You, at the end of your uni degree, you have a much richer experience. You become more employable, and at the end, you're gonna have more better memories, of what you did. If you are thinking about doing uni, my suggestion is to. And you want to go for computer science or information technology, my suggestion is to try to get as much knowledge in basic programming first, and maths as well, because that's going to give you a good foundation to tackle the first year courses. So we have students who come to uni without much maths knowledge or without much programming knowledge. And even though the university provides a sort of bridging courses for those students, they struggle a lot. So if you can learn some of those skills beforehand, that's going to make your journey easier, through uni. And the thing is really universities is the best time of your life. I love my uni degree. I love my time at uni. And I enjoyed every minute, even the frustrations and in doing badly in an exam, that helps you grow as well. Now, not only the things that went right, but the things that went wrong. If you see what went wrong with a critical eye, that's where you get the lessons from. Yeah. And just have this perspective of you are in an environment of learning, of knowledge. Take as much advantage as you can of that.
For those who would like to get in touch with you to ask you a question, what's the easiest way for somebody to reach out to you?
So there are two main ways. If you go to the university website and put my name on the search bar, Alexandre Mendes, my link, there's a link to my staff page that is pretty much the first hit. And you can also Google my name. Just make sure that you spell Alexandre with an R-E at the end, because otherwise, if it's Alexandre Mendes, you will end up with on the webpage of Sam Mendes, the film director, because his name is Sam Alexandre Mendes. So you end up in his page, and it's definitely not me. And or you can find me on LinkedIn. I'm there as well. And if you want to contact me, just send me an email, or you can call my office, and I'm there pretty much all the time.
Very helpful, insightful for me. Hear about your takes on university, AI, work integrated learning. There's a lot there to unpack. So I really appreciate your efforts today.
Thank you so much for having me.
Yes, man.
Thank you.